I'm Molly. I work for ThoughtWorks. I live in Chicago, so not native to Atlanta, but it is much better weather here, so thank you. I have done this talk a couple times at a tour conference series called No Fluff, Just Stuff. And I've gotten this question a couple times about what really are you talking about? Because the title is a little bit misleading or can be thought of in a couple different ways. A lot of people think I'm talking about migrating from something to NoSQL. I have done that, and I will talk a little bit about why you might think about NoSQL databases at the beginning, but the talk is really about considerations for data migrations in NoSQL, how they kind of compare to when you're doing data migrations in SQL, and some of the different options that you might have with NoSQL databases, and then when you're looking for tools. I won't give any specific tools because they vary so much by database, but I will talk about things you should look for in tools when you're looking for migration tools. So I just want to be clear because I do get that comment a decent amount. Are you going to help me move from this database to another? That's not exactly what this talk is about. So to start, I like to ask, can I just see a show of hands of who has worked with a NoSQL database? Doesn't matter what kind. Cool. So I guess some of you will have a fair bit of context on some of migration tools, and what I mean by NoSQL. So NoSQL in general just means we are going from this, rows and columns, to something that represents data in possibly any different form, something that is not that. So that is the general definition of NoSQL. What I like to kind of talk a little bit more in detail about is NoSQL databases, to clump them together is really hard. They're very good at different things. People will ask why you might use Mongo versus HBase, or two different key value store databases. They all are very, very good at certain things and very bad at certain things, and they are similar in some ways. And so a couple other similarities of, in general, NoSQL databases are scalability. So a lot of NoSQL databases have better ability than maybe a SQL database or a relational database to scale up a little bit better. Other things that people look for are better with continuous delivery. So those are some things that are maybe more in common about NoSQL. What a little bit more about NoSQL. So NoSQL has become more popular a little bit because we're trying to look at different things and actually take data and look at it in the way that it might be represented better than rows and columns. So my example here is a log file. I've worked on projects where you just dump things into a log, and that's all you do with a log file. And one of the arguments for document databases that they're very good at is maybe logging your data could be done in a document data store, and that could be a very good use for that because logs can be very disparate in what data you're logging, but they can all be JSON objects. So a little bit more on why to use NoSQL. Because a lot of people might say, well, I can do everything in SQL. I was working so ThoughtWorks is a consultancy. I was working at a client, and we were talking about bringing in Mongo. Mongo is probably the NoSQL database where I have the most expertise. So we're talking about bringing in Mongo for a CMS that we were building. And I had a decent amount of conversations that all kind of revolved around, well, I can do this in SQL. Why would I use a NoSQL database? I don't have the capability in-house. I don't know that I want to bring it in-house. What's it going to cost me? All these questions, but mostly, I can make this in rows and columns. Why should I do this? Now, my first answer is, why put this is the best representation with, so if you've seen ThoughtWorks presentations recently, or our website, we have these things that we call our glyphs. So this is my glyph representation of putting a square peg in a round hole. That's my first argument when someone says, well, I can do this in SQL. That is probably true. I probably cannot argue my way to saying you can absolutely not do this in SQL. I bet you can. I bet that is possible, and I bet that might be painful. Now, it's not going to be painful because it's not going to be painful in some ways. SQL is a very well-known language. So coming back and saying I can do this in SQL and it will be, that's what I want to do. If the thing that you're worried about most is in your organization, SQL is basically the only capability you have, and your use case is not so dramatically different than rows and columns, maybe SQL is fine. But there are things like, last summer I was doing a project and we were trying to understand the domain a little bit better, and we realized it really was a graph, things connected in different ways, and we said, well, maybe rows and columns is not the best way because, and then we started talking about features of Neo4j. And we realized it was dramatically beneficial for us to be using something that's a NoSQL database instead of trying to fit the square peg in the round hole. I mentioned this one already, but I think it's an important point to talk about. Scalability is something that a lot of NoSQL databases have the capability to do easier, not only just scale up, but then scale back down. This argument is used a lot in the fact that when users are using web applications now, when are those peak times? Or is it all consistent? What kind of data and usage patterns are happening on your application? So do you need that same availability and scalability of your data stores all the time? Or do you need to scale up and down? One of the things that I think of when I think of this is I think of myself buying tickets for a concert or tickets for some show or game. I always think about how I'm accessing, say, Ticketmaster or a ticketing website, and everyone's doing it at the same time. Well, maybe you need more scalability, and that's an application, but the same can be said about your data. Maybe the access of your data is being used differently. Maybe you're writing a lot at one point in time, but then you don't need to do that again for later, until much later, or relatively later. Maybe it's a pattern. So scalability is something that with the different usage patterns of the web, you're not just reading things consistently, that NoSQL databases tend to do better. This picture is not really the best portrayal, but I tried to find a better one. Some people want to use NoSQL because it is the new thing. It is a new thing, and it's a new thing to introduce to your organization. Sometimes that helps shortcut some of the process that you already have built in around changing data in a SQL database. Sometimes it shortcuts, sometimes it can bring in better new practices into your organization. I don't recommend this as the reason to bring in NoSQL to your organization. If there are problems with how you change data, how you change your data stores, how you work with work as far as developing software, that's probably a different problem than what bringing in a new data store should be solving. It can help forcing some of those conversations, because you need to think about a NoSQL database differently than, say, your regular relational database. But it is not the reason to bring in a NoSQL database. But say we decided we have a use case and we know NoSQL is the right way to go. That's why we came to this talk. So great, we know we want a NoSQL database. There's a guy at ThoughtWorks that has written a couple books all on databases. His name is Pramod. You may have read it. He helped write NoSQL Distilled. He also helped with this tool called DB Deploy. He helped start around the thinking of migrating data in a database and how can we make that change easier. So I want to talk a little about what does this do for SQL databases, kind of, and then what does that mean for a NoSQL database. But first, I've heard this argument on, well, NoSQL is commonly thought of as schemaless. Why do we need migrations? There's no schema. Migrations and migration tools like DB Deploy are very valuable for things like keeping a schema and changing it. But the argument is made, but if you have a NoSQL database, you don't have a schema. Why do you need to change it? I know schemaless is one of the terms used for NoSQL, but I don't know if that's a completely true term. Schemaless. It might be a more flexible schema. It might be something that is not quite your stiff rows and columns, but there is some sort of schema in NoSQL databases. There's some sort of structure that you're trying to follow. This example is the fact that if you're storing, say you're storing people in a NoSQL database, you probably have an ID. You have things that you want to be able to quickly find an entity by. For me, and a lot of people, we have names. Even just having two things that are common fields means that you have some sort of schema. It doesn't mean that you have a really tight, rigid schema. And in a lot of NoSQL databases, maybe you don't have to type everything, which is different from relational databases. So it is much more relaxed. The other thing is that you still have pieces that interact with your NoSQL database. So you're not going to just create a database without an application. You're not going to create a database that you can't use and understand things that come back from it. I'm not used to having a microphone strapped to me, sorry. There's contracts between your database and something. So being able to have an understanding of what those contracts are, what you can expect from a database, it's not a schema, but there's an API of some sort and you have some expectations of what's in your data store. So back to why we started talking about this. DB deploys, one of the benefits that it has is to be able to change that very rigid schema in relational databases. Well, I think there's still a need to be able to understand the structure, flexible or inflexible, as it is in a data store, and be able to change it over time. That, I think, is a better definition of what DB deploy is doing, is changing the structure and being able to have that in some sort of predictable fashion. I want to kind of go into why data migrations are hard, because this talk is not valuable if migrations are easy. If migrations are an easy thing to do, everyone would be using them. If they're valuable, everyone would just be doing them, maybe like building a war, I guess. But I've been on projects where there have been no migrations written, and I've come into the project and I said, well, how do I change this database? How do I use it? And no one's doing it. And it's really hard to change or add features when you don't have anything that makes it easy to change your data. So migrations are hard for a couple of reasons, probably more than what I'm going to talk about. So first, think about how easy change is in your organization. How many layers does it take to add a piece of information to a data entity? Usually, when we go into clients, that's one of the things we ask. So one of the things we use to assess is a question I like and I learned from another thought worker was, how long does it take to deploy Hello World? And include in that Hello World is maybe stored in the database. And that's a really good exercise to see where the pain points in your organization are by going through all of those steps to figure out how long would it take to deploy Hello World and include something where that means you have to update a database. The other term that I learned in the same exercise is, can it be done by lunch? And I like that, that's a good measurement for me, is how easy is something, can you do it by lunch? And usually the answer for this, when we usually ask it, is no. No, it cannot. No, we need to talk to this person. We need to file this ticket. We've got to run tests, hopefully, go through CI. There's a lot of things that need to be done. But we want to make it easy. We want things to be easier. That's one of the reasons tools like dbdeploy have been introduced. Another reason, and I mentioned this a little bit, is if you think about an organization, these are just some of the areas that areas of people that are involved in application development or creating value to a customer. So we have application teams who are doing development. We have business who understands what users want, and we have infrastructure, architecture, operations that helps with keeping an application up. Now, why am I talking about these people? What do they have to do with data migrations? Well, it's important to think about, they all are probably involved with how you get Hello World up and running. But it's important to think about things that are priorities for these groups. And that, because these priorities are different, that means that change is harder because you're trying to figure out which priorities are more important, which have to happen. So, for an example, application teams are usually encouraged to get features out early and often. I went to a talk about security by Rosalie and Jack, who I work with earlier, and they were talking about PMs should be involved in security because they are the ones fighting for more time for security. And they're also usually fighting for time for features to be delivered. And usually they're the ones pushing you to say, we want it done earlier, more frequently. So that's a priority of the application team. Get things out more often, which includes data changes. Now, if you think about maybe in the infrastructure and operations side, we want to make sure these changes are safe. We need to make sure we're not going to bring down all of our systems. We need to understand and be able to support this application. These aren't necessarily competing goals, but they make change harder because we need to figure out A, where the priority is, and B, how we can kind of balance between all of these. The other thing to think about between some of these different groups is where does the responsibility for data live? So if you have application teams developing features, they understand what's changing about data. You have business people that understand what data is important, what data is valuable to understand about our customers. You have the operations who, in lots of organizations, they're actually in charge of making sure databases are up and running, making sure the right people have the right access. So all these people, in some way, are responsible for the data of an organization. That also makes change harder. That makes understanding your data and changing it harder. So what happens when change is hard? Well, this is one example of you do it less frequently. So this is a calendar, and I did some research, and I've never actually had to do this, but you do a migration at the end of a sprint or on a weekend. You do it very infrequent because it's painful and it's hard, and you don't want to do that often. Well, these all cause problems. Not doing things frequently causes problems of you don't get that feedback early, you have bugs. It comes down to probably a waterfall at the arguments between using waterfall and agile. A little bit is what happens when things are hard. You do them less frequently. Sorry. So a good question at this point is, are migrations actually more difficult with NoSQL databases than they are with SQL databases? Well, I'd like to come back to the fact that dbdeploy is a tool you can use. And with SQL databases, it's almost a solved problem. There are many tools. Liquibase is another one that you can write migrations for SQL databases in. Why do I say it's a solved problem? Because SQL, relational databases, are all the same. One thing that makes NoSQL databases more difficult is they are different. You have them written in different languages. You have them where it's a graph versus a key value store versus document. You can't migrate those databases with the same tools. You can't migrate them in the same way. For example, like I said, I'm most familiar with MongoDB. Mongo is much better on the read side than the write side. So when you're changing Mongo and the structure in Mongo, understanding what you're affecting by changing and writing to it, how fast that will happen, you have to make different considerations for Mongo than maybe other document stores. I want to point out that I think collaboration around migrations is key, is one key for making things easier. The different areas, because data lives within all of them, they all affect the data of an organization. I think collaboration is key to making it easier. And along the lines of doing things more frequently, it's scary to do migrations if you do them every weekend. One of the things that I've done on teams is we started off with migrations. It's easy to say, oh, we just won't migrate the database until it goes to production. But then you have to migrate it every time you want to change something after that. So why not start with adding in migrations? Both of those things are not different about NoSQL. But, sorry, I didn't get off this point apparently. Build in your migrations to your continuous integration, continuous delivery pipelines is an important step. And do it for your deployment step as well. Don't just migrate them in your dev environments. Migrate as you're going along through your environments. Sorry, I almost feel like we skipped a few slides, but so I want to just back up and okay. I'm not sure what happened to the slide decks, but okay. Refocusing to go back to why would NoSQL be harder or easier than SQL migrations? Like I said, it's hard to migrate NoSQL databases all the same way. You can't write them the same way. But there are a couple of different options that I think should be considered with NoSQL databases. So thinking about this, we need to think about what data we're saving. We need to think about how we need to be accessing it. An example of this, to think about what migrations to write, think about maybe a global company needs to have access to applications and the data for those applications 24 hours a day. That might change the migrations you need to write if, for example, in comparison to a company that is local to only North America. Why does that change the migrations? So if your data is accessed 24 hours a day, you need migrations that don't take down or affect the time up of an application. If your data is only accessed for, say, 15 hours a day, you may have a little bit more flexibility around your migrations. Similarly, how much do your operation teams need to understand what migrations are written? Who owns that piece of supporting the data? So going back to those 3 vague areas that I had up on the slides earlier, understanding those priorities affects the different migrations that you're writing, and involving all those stakeholders early on in conversations about how data is used and accessed and changed is important to affect this next piece. So we're going to take me and add some favorites, some favorites, probably websites or something. So I'm going to go through 3 options that I see in the NoSQL world for how you migrate data. So option number 1 is lazy migrations. What I mean by lazy migrations is that you don't do them all at once. So 2 examples of how you might kind of write this code. A lazy migration is basically you get some data and then you need to change it somehow. And then once you resave it, update that data again, it has been migrated. So every time a piece of data is accessed, it's been migrated. Example 1 is just saying, if you get a person, if it has favorites, return it. Otherwise, you return nothing. And then in turn, when you save a person, again, it will save it with an empty list of favorites. Example 2 is writing that same thing in a separate function. So I want to kind of talk about a little bit of the benefits of example 2. First, having a migration separated out And this would be run every time a person is pulled back from a repository, kind of as a middle step from getting that and then putting it into the application. This can be tested separately, which is advantageous for this example. The other thing is example 1 clutters up your application code. So that's a migration that's part of your code. It's still lazy, so you don't have to do it. So it only happens when things are updated. But you may want to prefer option 2 because you can test it separately, and you can separate that in your code structure as something different, as a migration. So just to kind of hammer home this point of lazy migrations, not everything is updated all at once. Data is changed as it's accessed. Let's go over some of the pros and cons of this. So I skipped over some slides that talked a little bit about making sure that migrations are built into your CI pipeline. Make sure you're doing them often and getting that feedback from them. With these migrations, these are all done in your application code as your application is running. So when you think about the CI pipeline, you may not need an extra step in there. So if you're doing migrations as a separate step, as a separate process, you need to have that tested. Well, if it's part of your application, then there is some benefit to reducing some complexity of your CI pipeline. Everything is migrated already when you access it. So that may mean that your testing is easier. You know that you can bring up data and it's already done. It's already in a new state. You don't have to go and make sure that migrations were run somewhere. You don't have to make sure that in your development database that piece of code that's a migration is already run and checked in along with the application code that it's being used in. So testing could get a lot easier if you have migrations that just change the state of the data as data is being accessed. Now, the other piece is that you can write unit tests for these migrations. Both examples were pieces of code in the application that you can write unit tests for. The first one will couple the testing of the migration with your application. The second one has the advantage of being able to write migration separately from your application code and also test it separately. So testing might be a little bit easier when you have migrations that run with your application. But I think it could also make it a little harder. How do you know when a migration fails? How do you know when something goes wrong with a migration? So the unit test, when you have migration separated out of the application, that maybe you can test with some negative test cases. On the converse, how do you know what your application does if you're trying to access a piece of data somewhere else and it hasn't migrated that yet? How do you test for those edge cases when your migrations don't happen, or you're trying to use data that isn't migrated yet? I think for probably the 80th percentile, that's a made-up number, obviously, the test cases will probably be easier because it's part of your code, because you can use it inline and you can unit test it. It's probably easier. But there's edge cases that I think probably will go unnoticed, and maybe bugs will happen later on, which they are harder to fix later on. So maybe testing could be harder. Um, there's another there's another thing that could be harder when you have lazy migrations. So when you have lazy migrations, you may have different versions of the same data. You will have different versions of the same data in your database. So going back to the person example, I am a user of Twitter, but I am not a super user of Twitter for sure. If Twitter is updated in the last, so I used it today, but probably in the last couple of months I haven't used it. If Twitter were using a lazy migration strategy, I wouldn't have accessed my username for quite some time. So before today, if they had added favorites to Twitter, like my example up here, they would have had to support two versions. The people that are the active users of Twitter that already would have favorites, and me, the one that has a Twitter account but rarely gets on it. Now, if you think about this in a different situation, it's there's many versions if you have a lazy migration strategy. There's versions of the super users, the people the data that's accessed all the time, and then there's the people that never use something, and then there's a lot of different versions in between. If you're adding features often, you may have different data is accessed differently, and you're not going to be able to say, okay, we can stop supporting this version because everyone's updated. You'll never know, well, besides from the application, when you can get rid of this piece of code or this migration. You can never say all your data is at this state with lazy migrations. So if you're using, especially with the first example, if you're putting your migration code in your application code, when is it safe to take that code out? When is that code stale? You don't know. And similarly with the example 2, since it's separated out of your application code, it's a little bit cleaner. But when you think about the migrations that you write for applications, they grow substantially. The number keeps growing. So when do you know that that has run? Is it starting to take a long time to run all of those hundreds of migrations, going through all of them if a piece of data is accessed? Versioning can be a real problem in lazy migrations. This is one benefit to lazy migrations is hopefully you have less of this. Going back to that example of the global company that needs 24-hour access to data. If you're doing lazy migrations, you shouldn't be getting a 404 page because your application was taken down because you had to migrate your data. We should be able to, as we update the application, also update the data as it goes. Now, this is dependent on an application deployment continuous delivery strategy. This is maybe making an assumption that you're using maybe a blue-green strategy to deploy your application so you have no downtime there. All I'm really saying is that if your data is migrated through the application, you don't have any additional downtime because of your database migrations. Obviously, if you have downtime because of deployment of an application or other subsequent systems that you depend on, this is not fixed completely. Kind of going back to that versioning thought a little bit is in that extraordinary bug case. What happens when something is missing? So the example I'm still using is I don't have favorites in my data entity here. What happens if some piece of your application thinks that that's going to be there? how do you know that the code coverage, that your code is covering all the time for assuming that you do or do not? How do you know that your code is making sure that you are covering all those versioning cases? I think that with the lazy migrations, it gets a lot harder to make sure that there's no bugs when you have different versions in your system. I think it's probably a problem that is more likely in example 1 than example 2, but it's still a problem. So I'm going to move on. I don't remember exactly what this slide is for, and I have no notes. The next option is my option 2 out of 3. And this one is the opposite of lazy, so eager migrations. As you can tell, I am a dog person, and my favorite kind of dog is boxers. db-deploy falls into this category of eager migrations. And a lot of tools that are built probably go to this category first. There are several tools that fall into the lazy migration category, but this is probably the more common usage pattern of migration tools. So the difference between lazy and eager is going to happen no matter what. It's going to force a change in the data in your database. It's not going to wait until you access data to change it. It's going to change it whenever that migration is run. So it's going to take this person and every other person in the database and add favorites to them. Probably the migration would say an empty list of favorites, but maybe a migration would say, by default, everyone has these 2 favorites. So what does that benefit us? Or maybe let's first look at what that might look like. Going back to Mongo again. For Mongo to write so when we started with a client several years ago, there were not a lot of good migration tools for Mongo, and we actually wrote our own, and we wrote it through using the JavaScript console, which is how you access Mongo on the console, is by using JavaScript. You can interact with the data that way. So this example is a pseudo JavaScript code. So you're saying for each user, you're going to add an empty list of favorites, then update the database with this new user that has favorites, and it would go through all the users. So no user is going to be logged into Twitter and not have any favorites. Everyone gets favorites. So what's good and bad about this approach? First of all, you can access those new fields for everyone. It's a guarantee. You don't have that state where what happens in your application when something is missing. You don't have that state because you're forcing state. You're forcing everything to change all at once. So you won't have those bugs. The problem with that is you don't know the different versions. So in the lazy migrations state, you may be able to say, oh, this data is back on, has never had XYZ migrations run on it, so maybe we can archive it. With migrating everything eagerly, there's not a lot of distinguishing characteristics to say, oh, we never access this data. You're forcing those changes. So you may have to add additional fields that are not domain specific to talk about, that give you indications of how often is this data used. And maybe some other characteristics that if you're only changing data as it's accessed, that might help you in a way, in the operational sense of how do we know this is good data, or what the structure for these type of users should be versus these. So right, eager migrations, you may have to add some things to get a little bit more information from your data.
In your case with updated, that's already encoded into the ID of Mongo. Like,
yes.
That works, right? So
yes.
You wouldn't actually need an updated date.
Well, yeah. In my case here, this one.
I mean, specifically with Mongo, because of course they encode the actual date time into the ID.
Yeah. So you're right. Depending on the database, it might already do some of these things for you. It might be able to help you with understanding whether or not when the last time your data was updated behind the scenes.
If I have 1 million records in your case, how long it would take to migrate all of them?
You're going to make my points for me, aren't you? I will get to that in a second. In the case of eager migrations, they almost have to be outside of your code. You can't have them in your application code. So an advantage to that is you don't have to write that extra code. You don't have to write that check in your code to say, has my data been updated? Has it changed state? So you might have cleaner code with eager migrations. This argument was not made by me. It was not. This next one is not originated by me. But with these migrations, you get to walk a lot of miles, or you go through a lot of miles before they get to production. So they're well tested. That argument means that when you're doing eager migrations, everyone has to do them all the time. And they're done for every local station, for every local database copy, for every time you go to a new environment. Because eager migrations are always forcefully run, maybe you have more trust in them. I'm not entirely sure that's the best argument because with lazy migrations, they're still always done in those environments. It's just based on how you access data. So you may have to do more with your testing to make sure that you get those miles on the lazy migrations as well. But with eager migrations, because you have to do that in order to run the application code and make it work, the migration has to be run for the new application features to work correctly. You are going to actively run these migrations, find problems with them, fix them early. Now getting back to your point on if you have 1 million migrations, or if you have 1 million records in your database, you might get more of this. It might take longer. So how can you mitigate that problem? Because having more time spent migrating your data could cause you more downtime in your application. It's possible. How I've seen that mitigated is by having different databases that you run the migrations on and then switching to it. Maybe blue-green strategy there. Depending on the database, it may use eventual consistency. So you could migrate one of your replica sets and switch your primary node while you're doing migrations. There's some strategies to avoid more downtime with eager migrations, but it is a possible detriment for eager migrations. Now, there's also tweaking that can be done in these tools that are eager migrations. So, and we actually never found that as a problem for any of the applications I wrote. Migrations can be really quick. We never found a performance problem with them, actually. Okay, I'm doing okay on time, but the third option is all the things. Originally, when I did this talk, I didn't actually have this as an option, and I talked through it with someone in the audience of the first time I gave this, and they said this is actually how they did things. And I wanted to include it because it's true. There are some good things about lazy migrations, and there are some good things about doing it eagerly, around the predictability versus performance, around being able to see how your data access patterns are versus making sure that you don't have all the extra oddity bugs. So I don't have a lot of points on why this might be the good strategy, but you can see pros and cons to the first two options. A suggestion might be go with a lazy migration strategy, but do it up to a point where you need to change everything and you want to say, all right, now we're moving to this version. It's kind of like, well, if Angular gets to Angular 2.0, they're going to say you either need to stay with 1 or you're moving to 2 with us. So when you can probably have that flexibility in your data structure to a point. You can say, all right, as this data is being accessed, we'll update it. Now we need to update everything because we want to make sure that we have clean code. We want to make sure that there's some predictability. Maybe before you do update everything, you can archive some, so you're avoiding maybe some of the performance problems. But I think this is a viable option as well. You get a little bit of both of the pros and cons. So at the beginning I said I'm not going to go over specific tools. A lot of the different NoSQL databases, especially since in the past maybe 5 years, have also had migration tools built for them, whether or not it's in the database itself or through the people that create and support the database, or definitely there's several different tools on GitHub for almost all NoSQL databases. So things to consider when you are looking for a tool to migrate your data with NoSQL or SQL. What are your data access patterns? If you need that uptime, maybe you need to think about the lazy migrations as an option, or maybe the third option of doing a combination. Data access needs to be important when thinking about the migration tool because we don't want it to be a limiting factor in this. Test creation. So when I talked about when we wrote our test, or when we wrote our migration tool for Mongo several years ago, we also wrote tests that we were able to test all the data as the database migrations were run, that they were run successfully. Don't choose a tool that isn't going to let you and help you understand that migrations were successful or failed for some reason. Make sure that is not a limiting factor as well. Deciding whether or not you want to be able to, so I called this up-down. If you're familiar with Rails, this is the default. Can you change your data one way, and can you revert that? When you're looking at tools, think about whether or not you want to be able to revert that migration or not. When we were writing our migration tool, we decided this wasn't a thing we wanted to support. And some migration tools do not support rolling back migrations. Instead, it's always going forward, always thinking of it as a change, whether or not it is changing it to go backwards. So some tools do support rollbacks and some do not. how do you avoid conflicts in your migrations? A lot of tools do it through naming conventions, but how do you make sure that one migration is not going to affect another, or if it does, how does it mitigate and tell you that your migration is also the same or affecting similar things as something else? What kind of feedback does that tool give you? And lastly, is it applicable for the language that you're writing in? Sometimes NoSQL databases have a couple different versions of a migration tool in different languages. Do you have that skill set? Is that something you want to learn just for the tool, for the NoSQL database? I think a lot of them are closely tied to the NoSQL database. So if you are committed to learning about that new database, the tools for migrations are probably not too hard to learn as well. But it's something to consider. So I want to hit home on this point of data is not just in one area of your organization. And writing migrations should be a thing that's done, but the type of migrations that are written really affect a lot of things, not just how data is changed. They affect a lot of different priorities that people have. So making sure that the migrations that are being written will help, not harm, all people that are involved in what data is important is a really important piece to consider when you are thinking about migration tools and the types of migrations you're writing. With that, I want to say thank you. And sorry about some of the slides that I either didn't take out or something, but are there any questions? All right, well, I finished about 15 minutes early, so you get a little bit of that time back. And if anybody, I'll stay around for questions if anybody has some. Thank you.